In this lesson, the objective is to prove two triangles congruent using the angle-side-angle postulate or the angle-angle-side theorem. In the first two lessons that we've had, the first lesson we used the definition of congruent polygons or the definition of congruent triangles to determine that two triangles were congruent. In the second lesson, you learned that you could use just the three sides for side, 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 or you could use two sides and an included angle for side, angle, side to prove triangle congruence. So we're going to add two more postulates and theorems in this lesson. In the first one, the angle, side, angle postulate, it states that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then those two triangles are congruent. So in this diagram, we have angle A is congruent to angle D. So if angle A is congruent to angle D, and we have side AC congruent to side DF, and then we have angle C is congruent to angle F, then we can say that triangle ABC is congruent to triangle DEF by angle, side, angle. And note that the S is in the middle intentionally in the abbreviation for this postulate, angle, side, angle, to indicate that the side is included in between the two congruent angles, two pairs of congruent angles. So let's scroll down and look at the next theorem. In the next theorem, we have the angle-angle-side theorem. It indicates that if two angles and a non-included side, so a non-included side, one that's not in between the two angles of one triangle, are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. So in this diagram, we have angle A is congruent to angle D. So if angle A is congruent to angle D, and then we have angle B is congruent to angle E, and then we have side AC congruent to side DF that's not included between those two angles. And it's the corresponding side in each one of those triangles that's not included. So we have AC is congruent to DF. Then triangle ABC is congruent to triangle DEF by the angle-angle-side theorem, where the side is not included in between the two angles. Let's look at the problems for these postulates and theorems. In problem 1, it asks which two triangles are congruent by angle, side, angle. So you're looking for two of these three triangles that have corresponding congruent angles, two pairs of corresponding congruent angles, and the side that's in between those two angles is also congruent. So if we look here, in the first triangle on the left, angle CBA, we have angle B, and we have angle A, and we have a side that's in between it. So we need to, that matches the criteria for angle side angle, but we have to look for another triangle that has those corresponding markings on it. The second triangle has the right angle on E, and it has angle D marked, but the side that's marked is EF, and it's not the side that's in between those two angles. So it's not the correct side. Let's look at the third one. The third triangle, we have angle K is the right angle, angle J is the angle that's congruent, and you have side JK that's in between them that's also congruent. So these are the two that match, is the first triangle and the third triangle. So we have triangle ABC is congruent to triangle JKL because angle A is congruent to angle J, angle B is congruent to angle K, and you have side AB congruent to side JK, which is between those two angles. So we can use angle side angle on that. Let's go down and look at problem number 2. In problem 2, we're going to write a proof using angle side angle to prove that triangle LMN is congruent to triangle PON. So let's do a 2-column proof. Statements on the left, reasons on the right, and look at the information that's given to us and mark it on the diagram. As we look at this, it tells us that side LM is congruent to side PO. So we'll mark that in the diagram, write that as our first statement in the proof. Given. Let's look at the other information that we're given. We're also told that angle L is congruent to angle P. So we'll just add that on to that statement for the given information. And we're also told that angle M and angle O are both right angles. So write that as our given. Angle M and angle O are right angles. So the next statement that we can make is that angle M is congruent to angle O because of the right angle congruence theorem. Which says that all right angles are congruent. And then you have everything that you need to prove that these two triangles are congruent. So our third statement is that triangle LMN is congruent to triangle PON because of the angle side angle postulate. In problem 3, we have another proof. We're going to prove triangle ABC is congruent to triangle ADC using the angle side theorem. So let's go ahead and do another 2-column with statements on the left, reasons on the right. And once again, look and see what the information we're given and mark it on the diagram. We're given that side AB is congruent to side AD. We're also given that angle B is congruent to angle D. That's also given. And we're given that angle ACB and angle ACD are right angles. So that's all the information that we're given. Once again, we can use statement 2 to say that angle ACD is congruent to angle ACB because of the right angles congruence theorem. It says that all right angles are congruent. And now we have enough information to prove that the triangles are congruent. Triangle ABC is congruent to triangle ADC by the angle side theorem, because we have two angles, two corresponding pairs of congruent angles, and corresponding congruent sides that are not included in between those two angles. Let's go down to our last problem, problem 4. In the last problem, it asked, which of the following best represents the answer and justification to the question, are the triangles congruent? So let's look at the information in the diagram that they give us. So they've given us congruence markings on angle URT up the top and on angle STR, that those two angles are congruent. It's also given us right angle markings at angle U and angle S. So we have two angles that are congruent. The question is, do we have any sides that are congruent? There are no sides marked in the diagram, but we can tell because it's a shared side between the two triangles. Side RT is congruent to RT because of the reflexive property of congruence. It's congruent to itself, and it's a corresponding side between the two triangles that's not included between the two angles that are the two pairs of angles that are congruent. So that tells us that we can use angle side to prove that these two triangles are congruent, because we have one pair of sides, which is the shared side between the two triangles, and the two angles that are not included in between that side.